Okay, let's solve the EOQ with planned back orders. We last left with this total relevant cost equation, which is a function of the order quantity Q and the quantity I'm allowing to back order B. And we have the three terms, the ordering cost, then the cost of holding inventory, and then the cost of stocking out, or the shortage cost. It's a continuous function, so how do we find the minimum value for this? We take first order conditions, set them equal to 0. Since I have two equations, I've got to use partial differential equations. A full derivation is attached in a PDF to this unit if you want to see that, but the end result is what's important. So we end up with optimal forms for the Q star PBO. That's the optimal quantity we're going to order, and I subscript it with PBO so we know it's for planned back orders. And then we'll also be able to determine the B star, the optimal amount we're willing to stock out. So the form of the Q star PBO is right here. I'm boxing it. Why is that important? Well, we're going to see that this ratio of CS over CE plus CS is going to be very important. It plays a big role going forward. And so we're saying that the new Q star PBO is going to be equal to the old Q star, which is the optimal quantity, the EOQ when back orders were not allowed, times the square root of CS plus CE over CS, which is just the ratio of the total, or the sum of the excess and shortage cost divided by the shortage cost. The B star is going to be equal to the Q star PBO times 1 minus that ratio of CS over CS plus CE. So if I know the forms for the new Q star and the new B star, then I can figure out my inventory policy. It's simply order Q star B naught when inventory on hand is equal to negative B star. Or comparably, I could say order Q star PBO, that new quantity we figured out, every T star PBO time periods. Now remember, once I figure out a Q, I know the T, and vice versa. So the important thing here is this critical ratio, this ratio of the cost of shortage divided by the sum of the cost of shortage plus cost of excess. We see that it plays a role here in the determination of B, and the inverse of it plays a role in determining what the new Q star is going to be. This critical ratio is something we're going to use a lot of going forward. So let's take a closer look at it just for a second. We know that the range that the critical ratio can take is between 0 and 1, right? Because CS over CS plus CE can never be negative, and it can't be greater than 1 since it's a part of the denominator. So on this chart I have here on the horizontal axis, you see it goes from 0 to 1, and this is the critical ratio, right? So this is the critical ratio on the horizontal axis, and on the vertical axis is the Q star PBO as a percentage of Q star. So it's the Q star allowing back orders divided by the Q star not allowing back orders. So let's take some extremes, because it's always helpful to look at extreme values first. So what happens if the CS is very, very big? Now remember, we know that Q star PBO, right, is equal to Q star times the square root of 1 over that critical ratio. So what happens as the critical ratio gets really big? Well, as you can see, as it gets really big, it can go up to 1. This term, right, this square root of 1 over CR will go to 1, which means that Q star PBO will equal Q star. So when it's really costly to be short, essentially not allowing it, if it goes really, really high, then essentially I'm going to order what I normally order for EOQ when I don't allow back orders. At the other extreme, what if CS is very small? Well, when it's very small, then we're going to make our Q star PBO will be very, very big. It'll be tremendously higher. It's essentially saying at the end of a year, I will place the order for all the demand that I had up to that year, because it costs next to nothing for them to stock out. So I'll order at the last possible time, and I'll order a very, very big amount. But I can plot this relationship for all the values of CR, and I get this kind of curve, which is very useful to see. And so now you can see that based on the ratio of how big the shortage costs are compared to the excess costs, that tells me and sets how much I'm going to order. And it's a trade-off again between the shortage and the excess costs.